hello, and thank you for coming along to this talk, Mecanim, Keeping Your Animations Safe from Coders since 2013. Before we proceed, allow me to introduce myself, this voice from above. My name is William Barr, but please call me Will. And at this point, I feel I just need to quickly stop and clarify that that's Will, as in the prince, as opposed to well, as in water well, or I'm welling up as a result of the emotional trauma I'm experiencing having endured all of these technical difficulties. Thank you for bearing with us. It's just I find that folk on the continent tend to at times struggle with my Northern Irish accent. I apologize. I was born with it, and for the next half hour you'll just have to endure it. Obviously you're free to leave at any time, but please don't. It would be terrible for my self-esteem. Anyway, getting back on track, our time is short, and before each of us are taken from this mortal realm, I'm very keen to share with you some of our studio's experiences with Mecanim and Unity 3D. But firstly, with what authority do I speak to yourselves today? Who is this strange sounding man you find, well, not before you. I really need to move off the script here, I feel. Who is this strange-sounding man you hear above you, and what does he do? Well, I'm Will, as we've established. I'm an animator and the studio lead at an obscure video game developer in Northern Ireland called BillyGoat Entertainment. We're currently finishing up development on what our accountant hopes will be our breakthrough hit, a 3D graphic adventure game called Her Majesty's Spiffing. A jovial romp through the stars tasking players with the creation of a galactic British empire featuring copious amounts of tea, self-deprecating British humor, and, of course, impeccable manners. And it's this game that is the source of content for this presentation. One final preemptive apology. Throughout Unite, you've had and will continue to have the opportunity to listen to talks from some truly gifted and experienced individuals, including Unity's own evangelists, folk whose job it is to go around and show you all the wonderful things that their game engine can do and the correct way to go about achieving some of the amazing results seen in some fantastic multi-platform titles. It is highly probable that some of the processes that we have implemented in the development of Her Majesty's Spiffing are completely wrong and nothing more than counterintuitive nonsense. But as they say, it's best to learn from other people's mistakes, in which case I'm certain you'll learn loads today. So let's crack on before anything else happens. I'm here today to talk about our experiences with Mecanim, Unity's powerful animation system. Mecanim is an incredibly important tool that is integral to the development of our game. It allows idiot animators like me through a very visual interface to preview the transitions between animation clips and set up the logic behind them without annoying our programmers. It allows us to quickly set up additive layers to add variety to looping actions, or even transfer animation between characters of different scales and structures. For animators, Mecanim is an empowering tool that allows us to work more independently without the constant reliance on our code-punching brethren. It ensures that the subtleties that only a draftsman trained to detect the slightest shifting of weight from one leg to another, schooled in the importance of the line of action, with an eye to spot the intent behind the most mundane gait, are maintained on screen. The animator sees light, shade, emotion, performance, anticipation, staging, arcs, timing. This is what a coder sees. These people cannot be trusted to put your animations in-game. I'm being facetious, of course, for comedic effect. Not all programmers see animation like this. If you're lucky, your programmer might see animation like this. And this is why Mecanim is so important. So let's have a quick look at Captain Frank Lee English, the protagonist in our game. Now, Mecanim can, of course, be used to control any form of animation inside Unity, not just characters. In addition, we use it to control our in-game UI, along with other inanimate objects, at which point they simply become objects, and so on. However, I want to specifically show yourselves how we went about getting Captain English moving inside Unity. So if we open up our animator window here, All of the animation clips that Captain English plays in-game are located in here somewhere. So something great that was introduced in Unity 5 were these entrance and exit nodes inside these state machines here. Or these subtrees here, sorry. This has helped us to vastly reduce the amount of sprawling connections between these individual animation states by, instead of making direct connections from one animation clip to another, we instead plug a connection into a subtree, which then within the subtree itself, we set up the logic behind the path for the direction that the animation will take. For an animator with a morbid fear of numbers, code, or syntax, this visual state machine is very non-threatening and easy to follow. Each animation is connected to each other via these helpful lines, with arrows illustrating the direction of the transition. But as great as these tools in Unity are to create these animation clips, it is most likely that you'll want to create the majority of your animations in another, more specialized package. And what a huge array of Autodesk PLC software solutions you have to choose from, eh? Obviously, if you're not compliant, other software packages are available. But to quote an old yet very appropriate adage, better the devil you know, which seems like an opportune time to talk about our Maya MotionBuilder FBX workflow. But these principles are the same for any other reasonably priced 3D software package. So, here we are in Maya. Typically, when I'm setting up my character rigs, knowing they'll eventually make their way into Unity, I set up a skeleton to have the same joint structure as a Mecanim rig. So, for example, I only use 2 spine joints, as this will allow Mecanim to transfer my animation onto its bipedal rig more accurately. Mecanim will ignore or try to compensate for additional joints, which may look fine in most scenarios. However, if you have animations of your character, say, manipulating items with their hands, for example, because the hierarchy has changed, things are possibly rotated slightly differently further down the joint chain, so your animations will not match their Maya source correctly. Also, I'm conscious not to interrupt the joint hierarchy from what Mecanim is expecting. For example, Mecanim's bipedal rig doesn't include a forearm twist joint, something most animators will want to finesse their wrist movement. There is a very simple workaround. Rather than have the forearm twist joint part of the hierarchy between the forearm and the hand, instead, we just have it parented to the forearm. We can create an avatar mask in Unity later that will let us to use these additional joints in our Mecanim rig. However, they cannot interrupt this standard hierarchy, or Mecanim will ignore them and prevent us from importing their keyframes. This is also how we go about adding facial joints or other joints for elements such as the character's clothing, things like epaulets or attractive man bags, previously known as satchels, back in a time when men wrought steel from the ground with nothing more than their bare hands, a time before fixies, MacBooks, Starbucks, and irony. But I digress. Just be aware that Mecanim will not be able to retarget these additional joints in the same manner as the main skeleton it's expecting. So if you notice some slight errors with these, so you may notice some slight errors with these if you're trying to use these animations on different characters with different skeletal structures. Another thing I like to do within Maya is ensure that everything that's going to be exported into the game engine is separate from all the gubbins I'm using to animate the character. The skeleton skin to my character's mesh is totally separate from the rig moving it. There are no IK handles or components attached to this skeleton. Instead, the rig drives a separate duplicate version of the skeleton, which in turn, through the connection editor and the use of some parent constraints, drives the actual skeleton that our mesh is skinned to, which you can see on the right of the screen. I'll then animate my characters in a separate scene using the reference editor to import my rig file. This, like using prefabs inside Unity, ensures that I can change the source file separately and reduce my scene size. This is very handy as well should you or your rigger add additional features to your rig through development. Finally, exporting our animation clip is as simple as opening the outliner, Maya's hierarchy view, selecting the mesh, shift-selecting the root of our skeleton, and going File, Export Selection. Just ensure that you're exporting an FBX file, and you want to include the animation, and you also want to resample the animation. This will bake your animation, setting keyframes on each joint for every frame. Fret not if you think this is wasteful. Unity will compress the animation once imported, removing unnecessary keyframes. Now, what we could do is simply drop this FBX file into our Unity project and crack on. However, there is one final step that I like to do to keep things a little bit better organized. We use MotionBuilder to store multiple animation clips in a single FBX file. By importing all our animation clips into MotionBuilder first, then exporting this new file into Unity, we can keep all of our animation clips in one place and significantly reduce the amount of clutter in our project. So now, let's step out of the darkness, back into the light, and return to Unity. Let's see. Now, before we jump back and look at our animation state machine, we'll just ensure that our FBX file has imported correctly. So I'll select here. I want to ensure that in my import settings that I've set my animation type to humanoid. So we're using Mecanim's humanoid rig. This will allow us to use these animation clips on other characters, retargeting the animation to account for different scales. And I also want to set up my character's avatar definition. So if I click Configure here, this is just to ensure that all the limbs and joints between the FBX file and the Mecanim rig are in sync. Mecanim is pretty smart and is usually able to work this out itself, but you can jump in and double-check everything should you be the fastidious type. I'll just click Done here. Next, on your Animations tab, it's probably a good idea to make sure that this Import Animation option is selected. If not, this particular tutorial would come to a somewhat abrupt, but perhaps not entirely unexpected end. And lo and behold, all your animation clips that we created in MotionBuilder or separated out in MotionBuilder, have been imported in this one single FBX file, thus negating the need to go through a load of individual files, cluttering your project, and setting up an avatar definition for each of them, and so on. So, the next nugget of wisdom, or glaringly obvious observation, I'll allow you to delete, whichever you think is appropriate, are our root motion settings. If I just find an appropriate clip to illustrate this. There we go. If I scroll down, small this down a bit. Here we go. So, for the most part, our character's movement is actually controlled by our animations. When our character walks forward, it's the animator driving its forward velocity. Originally, we used these settings in here, our root motion settings, to control the root motion of the character. So, for example, if the character was standing still, we'd simply lock all of these values here. And as far as Unity was concerned, this position in the middle here is the position that the character's in. So if the character's standing still, we'd simply lock all of these values, even if the character was sort of swaying side to side or making smaller movements to adjust their balance. We can lock the root rotation, the character's Y position, and their XZ position. Typically, if a character is walking forwards, we want to ignore his Y position, up and down movement, so we can lock that. But we probably want to unlock his XZ movement, so he's moving forward. More often than not, you'll want to simplify the root motion as much as possible. So if a character is walking forward, you probably don't want the position Unity thinks they're in veering left and right, even if they have quite a flamboyant gait. Sometimes we ran into issues, however, using these settings to control our character's root motion, most notably whenever we were transferring between two animation clips, or transitioning between two animation clips while the root motion rotation was updating. For example, if I load this video here. In this example here, our character is descending down a ladder, and once the second animation clip starts, they're immediately starting to turn. To smooth this transition out between the two animation states, we gradually increase the influence of the second clip over a short period of time. However, the root rotation of this second animation clip is gradually added, meaning if our character hasn't fully rotated at the end of the transaction, he won't be orientated correctly, thus being out of position whenever the character descends down the ladder. Let's see that again for reference. Our solution was to instead set up the root motion ourselves. I'll select another animation clip that I've done this for and find our ladder. So you'll notice here that if I select this motion tab, where I have the root motion node, so this is a node that's inside our FBX file, and I'm not presented with these options to generate the root motion within Unity. Now, this ensured that our characters are always aligned correctly for whenever they're transitioning between two clips, even if the duration of this animation or duration of this transition is very long. But let's talk a little bit about these transitions between clips, and of course one of Mecanim's most useful features. Now, as I said back at the start of my presentation, at some point between plugging our hilarious 3D graphic adventure game, Her Majesty's Spiffing, coming soon to Xbox One, PlayStation 4, and home computers, and my thinly veiled dig at a large production software company, I said one of the great strengths of Mecanim was that it allowed dumb artists, such as myself, through a very visual interface to set up all the logic behind our animation transitions. This is very helpful for other team members, in particular coders, as it gives them more time to refactor as opposed to implement any new features in your game. By selecting the arrows connecting our animation clips back in our animator view and this demo subtree that I've set up, you can control the transition properties. So if I open up this little settings tab here. So in here, we can control the duration of our transition, the exit time, or the point at which it starts the transition to happen in the first animation, and then as well as that, at what point during the next animation the animation is going to, or the second animation clip is going to start. This is obviously very helpful to ensure that as much as possible, all those lovely arcs and lines of action that you lovingly worked on at 3 a.m. the previous morning are maintained from one clip to another. One thing I should say is that when animating for games, you have to make compromises. You can't always have that long anticipation before an action because the player has already acted by clicking or pressing a face button. You have to compromise between what feels responsive and what looks believable. With gameplay animation, it's the reaction that's most important. You can quickly have your character's arm jump into position and press a switch, or punch somebody in the face, whichever particular genre you're developing for, over 2 frames, and then return to a more realistic or believable motion afterwards, and the player won't notice. They think they'll have seen all of the in-betweens, even though they haven't, because of this visceral act of initiating this action. What relevance has that to what I've been talking about? If truth be told, very little. It just took up a paragraph, so I thought I would keep it in to run time out a little bit quicker. But getting back to our animation state machine, you can see how quickly and easy it is to connect these different animation clips together. All I simply do is right-click on a node, click Make Transition, and these lines magically appear that connect each animation clip to one another. What you'll notice on the left-hand side of my screen here as well, I have this Parameters tab. So I can create, so in here I can start to create the logic behind these transitions and how they occur. So I can create 4 different types of parameter. The programmers amongst you will be familiar with them, but just to ensure that folk more interested in crayons are on the same page, the 4 types of parameter are a float, so any number, an int, an integer, any whole number, a bool, so something's either on or off or true or false, or a trigger, so something will be, well, triggered whenever we select this. So if I select one of these transition arrows to one of our animation clips that we have inside our state machine, and just scroll down to our conditions tab here, you'll notice that very simply, I can just hit the plus button here to add one or multiple different conditions, and I can just select this from my whole list on my left-hand side here of what condition I want and what the logic behind it is. So without touching any code, I can start to create the logic behind our animation system. It's very straightforward for our coder friends to find these parameters during runtime, and they'll be able to set up the points whenever these transitions occur. But in order to create a believable real-time animation, you're often mixing pre-made keyframe animation with procedural motion. A simple example of this is inverse chromatics, typically used for hand and foot placement. Any keyframe animation you bring into Unity within an FBX file will be FK. Each joint or game object will move relative to its parent, working down the hierarchy. IK works the opposite direction, calculating the rotation of its joints higher up the hierarchy first, maintaining the position of the child at the bottom. In Her Majesty's Spiffing, we implemented this, which as I'm aware that we're running out of time, so we'll just maybe move along past that second plug, or third plug, or whatever. I'm just shilling here, people, forgive me. In Her Majesty's Spiffing, we originally used IK to control the character's head rotation, and so whenever they were looking at objects in the environment. And this is what it looked like. But we weren't very happy with how the head rested. It didn't seem very natural, so instead we did this. A huge difference, as I'm sure you'll agree. Again, the subtleties of it, so on. Rather than use this IK lookat system, instead we set up additive layers in Mecanim. So I'll very quickly show you that. If I select my Layers tab here, we have this head rotation tab, which I've set up as an additive layer, and I've created this avatar mask, so it's only affecting the joints in the head. And if I double-click this is a new blend tree, a slightly different blend tree than what we would use to control the speed of our character, a point which, unfortunately, I didn't have time to talk about, but we'll very quickly try and go back to that in a second. So in here, we have a 2D, simple, directional blend tree, and I can use 2 floats to control. If I make this a little bit bigger, you can see the head movement, the left and right movement, and the up and down movement. So these 2 floats are set by calculating the horizontal and vertical angle from the position of our character's head relative to the point the character should be looking at. These are then converted to Euler angles and then plugged into 2 float parameters. Or so I'm told. It could very well be a tiny person inside the computer pulling levers. I just move things around for a living and occasionally color stuff in. We also use these additive layers to do the character's lip sync. So if I select this layer very quickly here, again, it's set up in the same manner with an avatar mask, so we're just affecting the joints inside the face. We just throw randomly in here all of these different animation clips without setting up any connections at all. Instead of using these parameters and the different connections through Mecanim, we actually use a plugin called Node Canvas, which I will very quickly throw up an example of how we set up the dialogue trees in our game. Here we go here. Which now, this is again another state machine, and one that looks very similar to Mecanim, except with the added advantage that you can do this. You can zoom in and out. It's truly remarkable stuff. So we use Node Canvas to create all the dialogue trees in our game. Additionally, we use this to trigger animation clips, camera transitions, and a myriad of other things that typically happen when our characters interact with each other. Thank you for your time.